so this week we're going to look at binary search. So let me step back before we talk about binary search. We already know linear search. So we have linear search or sequential search, and you need to be able to write that pretty easily. So what that algorithm does is if I have an array or a list or whatever, and I have some numbers in here, and I'm looking for the key or the the token or whatever. What I'm looking for is the number, I don't know, 10. Okay. So what I do is I just check each one. I start here at the first one. Is that 10? Nope. Move on. Is that 10? Nope. Move on. Is that 10? Nope. Move on. Is that 10? Yes. So I found a match because these two are equal. So therefore, I want to return, usually I want to return the index of where it's located. So in this case, I would return 3 back. Okay. If I don't find it, we should know that we return -1 if we don't find it. So that is linear search. All right. And linear search is good if we don't have a lot of numbers to go through. We can kind of go through it, and it works pretty well. But if I'm looking for something that's like 10,000, looking through an array that's holding 10,000 things, or even in real life, you don't do that necessarily. Okay, especially when the list is in order. So when we jump to binary search, this will only work if it is in order. All right, so that's what we're going to look at first. So please know, in order to do binary search, it has to be, the list or the array has to be in order. All right, so that's how we have to make sure we know that. So how binary search works, and we're going to kind of step through it a little bit. I'll show it here, and then I'll actually look at it at code a little bit, because we're going to have to get, it's easy to understand here, it's harder to write in code. So I'll start off with a simple list here. Here I'll put the indexes just to make sure that we're okay there. All right, and I got to put the list in order. So I'll put 5, 7, 9, 10, 13, 15, 18, and 20. Okay? And let's just start off. The key we're going to look for is 15. All right? So we're going to see if 15 is in this list, which we know it is in this case. So how binary search first starts is that we are going to take the list, the length of the list, and we're going to divide it by 2. All right? So we're going to take the length of the list, which in this case is 8. And we're going to divide that by 2. We can do the index of it as well. It doesn't have to be the exact. We are going to do the index of it because it'll be easier there. Otherwise, you're going to be off by 1 and you're going to have a problem. So let's start with 7. So 7 divided by 2 will still give us 3. Okay. So basically, this is my midpoint. All right, that is my midpoint. So I'm going to look there. I'm going to look at this number 10. All right. Is 10 the same as 15? No. However, I know that 10 is less than 15. Therefore, I know that 15, if it's in the list, has to be between there. So it has to be, if I change my color a little bit, it has to be on this side of the list. Okay. So now I just do the same thing, only with this side of the list. Now be careful, because this is going to be a little bit tricky to think about how we do this. So understand it first. So now the length of my list is 4. Okay. Now think about how we're going to have to be able to get that later on. So that's 4. And then 4 divided by 2 is 2. So now I know that I need to grab this spot, but this is spot 5 here. So think about kind of how we're going to do that there. All right, we'll kind of go through. So I need to grab this spot anyway, and I'm going to check. Is 15 equal to 15? And in this case, it is. So then I return 5 to the program. Okay, I return 5. Now, let's think about when it's not in there of what would happen. All right, and you're going to kind of have to think about that as we go through. All right, so let's start off and actually start pseudocoding this a little bit in binary search. So we're going to start off with our array. So that's how binary search works. Okay. Let's start with our array. And we're going to just go, I don't want to start with 1. So 4, 7, 9, 12, 14, 16, and 19. Okay. We know this is spot 0, 1, 2, 3, 4, 5, 6. How we start this is we start with a low and we start with a high. Okay, so we're going to say our low, I'm going to switch some colors here. Our low has to start at 0. Okay, and our high is going to start at 6. Now, to get the midpoint, we're going to add up the low plus high, so 0 plus 6, right, divided by 2 is 3. So now my midpoint, my mid, is spot 3. All right, or my mid is 3. Let's throw in a key here. Let's just kind of think about a couple things. I'm going to change the keys kind of as we go. So say we're looking for a 12. All right, and I'm going to erase this after we do this. So you look up here, a couple things can happen. Is midpoint is 3. I look at this spot. Is this a 12? And yes, it is. So it matches. So in this case, I would return 3 and I'd be done. It found it because I just want to find the first occurrence of it. Okay. So that's one thing that can happen. So one thing that can happen is you can find it right away. So the midpoint can equal the key. All right. So where you're looking can equal the key. And if that happens, you're good. You're done. All right. Suppose I was looking for 7. All right. So same thing again. Low is 0, high is 6, mid is 3. I look here at 12, and I look at 7. So one thing, the key can be less than the mid. Okay. Now it's not the mid. It's not the 3. Or the 3 can be less than the index of the mid. So the key can be less than the mid of where you're looking. All right. So that's another thing that can happen. And if that's the case, then, you want to move high. So high wants to get moved from there, and think about where I can go now. Erase a couple other things. Mid will be gone now because it's less than. So high can actually go all the way down to there. That's where high can go. High can become 2. All right. Remember, mid was 3, by the way. All right. High can become 2. All right. So now I do the same thing again. I look low and high, and I add them 2 together. 0 plus 2. We'll talk about why I'm going to add them in a second. It'll be more on the other end when you see it. So 0 divided by 2 is obviously 1. So now my midpoint comes right here. I'm looking here. All right. And I look at this, and sorry, I'm trying to write this in. My midpoint is 1. And I look at my key 7 and 7, and that ends up matching, and they're equal to the key, so I return. So that was the one thing that can happen. So let's keep going here. Let's erase the. Let's keep that as a 7, and we'll erase the key. We'll change the key. So I have this as a 7. Let's pretend my key is, in this case, a 9. Okay, this is the other thing that can happen. So I look here at this 7. All right, 7 is not equal to 9. In this case, is the third thing that can happen, is the key can be greater than the midpoint, and then where you're looking at the mid. All right. Now, if that's the case, then let me erase. I'm going to erase my mid. I'm going to erase my low, and my low can jump to the same spot as my high. All right. And now what I can do here is I can add these 2 up again. So 2 plus 2 is 4. 4 divided by 2 is 2. My mid goes here. So my mid is now 2 as well. So now all of these end up being at the same spot. And I'm going to look. Does 9 equal 9? Yes, it does. So now I'm back to stage 1. Now, if that's not the case, okay, then what's going to happen is these 2 highs and mids are going to cross. You got to make them cross because you got to know when you're done. And in our case, we know we're done. but we're going to have to tell the computer that we're done. So in my case, I know that we are done because I've checked everything. And when these two cross each other, when low crosses high, because you're going to have to move one of these, one will be in your else statement, these will cross. When low crosses high, you know that you are done because you need a way out. Okay, so when low becomes bigger than high or high becomes lower than low, that means that you have completed your binary search and it's not in there. And in that case, you would just return -1. Okay, we're going to kind of write it obviously in a couple minutes, but that is how I want you to kind of take a second to think of how that works. All right, these are really only the 3 things that can happen. All right, so once again, if I do this a little bit quicker, all right, on a little test here, let's look for, let's just change this out. Let's look for, kind of keep it, and look for the key. Let's change the key to something easier here. We'll go to 7 again, just to make sure we're good. All right, so my key is 7. So we start here, we have my low, my high. All right, my mid will be here. Then I check, does 7 is equal to 12? Nope, so that's not true. Is my key lower than my mid? Yes, my key is lower than my mid. So that means I want to move my high. So I erase my mid, and my high can move down. Now, a lot of people put their high here. I actually don't need to put my high here because I just checked that. That was my mid. You can move your high 1 less than the mid. Okay. And now I got to find my mid. Now my mid this time, my mid becomes here. Okay. So I check these, and boom, 7 equals 7. So in this case, that is correct, and I move on. All right. Let's do one last one. So let's change my key. Let's go up a little bit here. So my key will become, let's change it to 16 in this case. Yeah, we'll keep it. Let's change it to 19. All right, so it's the last one. I'm looking for the last one. So once again, low, high, mid, all right, 12 and 19, not equal. Excuse me, those are not the same. That's not true. The key is not less than my mid. 19, my key is bigger than my mid. So now I don't want to move high, I want to move low. And low can move 1 more than the mid. Okay? So now I'm looking here. Now think about this. I need this to be my mid. So I need to get 5 out of here. Well, how do we get 5? That's why we do the low plus the high, because 4 plus 6 will give me 10, and then when I divide by 2, I'll get 5. Okay, so when you're finding the mid, you want to do low plus high divided by 2, because that will get you here. Because remember, you're not getting rid of the array. You're not changing the array. It's not like you're throwing half the array out. The array is staying there. You're just looking at different spots of the array. That kind of makes sense. So now I look here at 16. Does 16 equal 19? Nope, nope, nope. So 19, it's bigger. The key is bigger than the mid. So now I move on. I'm going to move my low now to 1 more. Okay, and this is why you can't be done yet. So you can't be done. Think about how you're going to stop your loop here. You can't be done when high equals low. All right, because I need to check this because 19 is in it. So now I check, and then this, once again, let's see what happens here when I add these. So 6 plus 6 is 12. 12 divided by 2 is 6. So now my mid ends up being right here as well. All of them end up on the same spot. I checked, does 19 equal 19? In this case, it does. So I found 19 and I am done. Okay. Once again, if I was looking for something outside of the list, these two would now cross. So I need to have the high either go left or the low go up. Once they cross, then you know you are done. Okay. Hopefully that makes a little sense. We're gonna jump into Java to actually show. I'm not going to show the whole thing. I'm just going to kind of get you started. I want you guys to see if you can do it, to be honest, by yourselves. So that is how binary search works. It is really quick. Remember, it only works in order when the list is or array is in order. But it is a log n algorithm because you're dividing by 2 every single time. So kind of keep that in mind. It's definitely better than linear search, one if it's in order. All right, so let's jump to Java and take a look at that and see what this looks like. All right, so your assignment this week is to write both linear search and binary search. So if you open up Replit and you get to the assignment called search algorithms, this is kind of what you'll see. So very simply, I made an array, okay, and then I had to make a class called search, and I call the constructor, and I just send over that array. So let's take a look at what this does in the constructor. Very simply, I have an array, an instance variable called array that just gets set equal to the array that I send over. So basically, this variable array is this array. Okay. Then all I do is I have two functions. I call linear search, I send over a key, and I call binary search, and I send over a key. So what I'm going to do is I am looking for 13. So when I run this, I expect to get out, is that 3, right? 0, 1, 2, 3. So I expect to get out 3. Okay. And if I do it, I run, you can see I get -1 and then -1 for binary search. So both of them are sending back looking like it's not found. So your job is to come in and write linear search and get that to return the first occurrence of the value of the key if it's in there. If it's not in there, return -1. Then you have to do it for binary search. Now these two should return the same thing. So if I get 3 for this one, I should get 3 for that one too. All right, so just kind of keep that in mind. And you can check to make sure you're doing it the right. Like you can change this to 22 and then look for that index. So keep that in mind. You can change those and then hit run. All right. When you test it, I have other test cases that will test other lengths of arrays and different things like that. All right. So let's get you kind of started off with binary search. So to start off with binary search, we kind of talked about this a little bit in that you need to we have that low and we have that high. So the first thing to do is start off by creating low and creating high and thinking about what they need to be. All right. You can create mid right now or you can wait because really the mid comes after this part of it because we're going to kind of change those as we go. The next thing we need to have is that loop. So we need to continue doing this until low or while low is less than high. So if you heard me kind of say it there, we want to keep doing this. Remember when I talked in the video, we want to keep going while low is less than high. Okay, so kind of keep that of what we happen. Then once we get in here, you can find that midpoint. Right? Remember we talked about, I'll even put it here, is that midpoint will be this is what you want to look at, right? Because you want to get that low plus high divided by 2 and really understand how this is working. And then you're going to have 3 cases. You're going to have, the one case, you're going to have another thing that could happen, and then you're going to have the third thing. So that is really what you're looking at, okay? If we get out of this while loop, that means we don't find anything, and then we return -1. So hopefully you can get this working in binary search and really understand how it works. And if you understand this setup, that will really help for when we do next week recursion. I'll actually introduce it a little bit towards the end of this week. You'll see something on it, but that'll help for the next week when we get really in depth with some recursion stuff. So you kind of keep that in mind, but that's binary search to run through it. All right, let me know if you have any questions. As always, Schoology, message me, and good luck.